My name is Darren Pope, and this is DevOps Paradox. I'm going to add Victor in right now. Let's see if Victor adds in. Oh no.
Victor is not coming.
There he is.
Where is Victor?
Oh, I see you in the preview. Hang on, I'm going to boot you and bring you back. I'll add you back now. Why your video not work? Oh, come on.
I'll restart.
Yeah, restart. Okay, so Victor will come back in a second. Let me go ahead and he booted out. Great. So now I get to fill extra time. So we are doing another live episode today. This will be a bonus episode that ends up on the podcast, but this will just stay up in normal time. And once Victor comes back, let's see if he's back now. There he is. Dun, 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 dun.
There I am.
Okay, cool. So today we are talking more about the stuff that's happening in the world, the global pandemic, if you will. It's called Kubernetes. Oh, wait, is there another one? Okay, bad joke. So lots of people are trying to produce more content because people are stuck at home. You only can watch so much Netflix throughout the week. So we're trying to add a little bit more to your watching schedule. Okay, that was interesting. The magic mouse.
You're back. You're back.
Yeah, I'm back. I know. It's the magic mouse took me out today. So what we're going to do is we're going to talk some today about dealing with continuous delivery in Kubernetes. Now, we've got a couple of guests, so I'm going to slide off to the side. Victor, I'm going to let you go and start talking.
Okay. So we have people known as Jameses, James Strachan and James Rawlings. There you go. Jameses are here. And the idea is to speak about the changes and the phases we are in right now in adopting Kubernetes. Because at least in my head, and then you guys correct me, there were different phases. First phase was denial, kind of like this is a passing thing. It's going to pass away, so let's not go into Kubernetes just yet. And then we had a phase of everybody adopting Kubernetes by lifting and shifting things as they are. No, kind of like whatever our application is, we're going to run it in Kubernetes and we're going to live happily ever after. That's at least my theory. And now we are in a phase that we are realizing that it's not only about putting whatever we had or we have into Kubernetes, but really changing the way how we architecture our applications, the processes, basically changing everything, as if we're starting from scratch, right? We're monitoring in a different way, we're logging in a different way, we are doing continuous delivery in a different way, and so on and so forth. So that's my kind of like intro about the idea, what we should talk about. And now I'm gonna let James.
And I think I think that's true. And I think the thing that I love about Kubernetes is you can just lift and shift. You can just say, hey, I've got some VMs. Let me just put them on Kubernetes and not do much else, and it will kind of work. One of the interesting things, though, is the more you use Kubernetes, the more you learn the cloud native way or how to use the cloud well. So your first situation might be, I put a bunch of VMs in Kubernetes, and then you might say, let's decompose everything into lots of different containers. And then maybe you look at your use of persistent volumes, and you maybe look at using cloud storage or so on and so forth. And your entire journey becomes a fun journey, but you learn lots and lots about different ways of using Kubernetes well and using the cloud well. One of the interesting things is almost everything in software now, whether we're talking service meshes or network security or load balancers or storage or clustering or databases or messaging or eventing or serverless, or machine learning, think of almost any piece of technology now. It's being transformed to be more cloud native. So this is happening everywhere. It's happening to your applications you build. It's happening to the software you use to build those applications. So we're all on this journey together of making everything more cloud native and whatnot. The really interesting thing that I personally like about Kubernetes is once you kind of get your head around it, almost everything in the Kubernetes ecosystem works the same, right? It's custom resources, it's operators and controllers, and there's just lots of them. But there are very similar patterns in the way that Istio works to the way Tecton works and Jenkins X works, and all of these things work in a very similar way once you learn the patterns.
I think one of the amazing things that we're starting to see around that is that's because of, I guess, open standards and the nature of being open source. We saw kind of standardization around from how to extend Kubernetes, which people then start developing these controllers and operators and in a similar way, which means we have this rate of innovation where people are using the consistent way to build these things and how they work, but the innovation is then growing. And so we have these service meshes and all the list that you just mentioned there, James. I think we're really starting to see the benefit in the industry of this, the nature of it being open source as well. One of the other interesting things as well, though, is it's what people then maybe, from Victor and what you were saying at the start, people kind of initially do like this lift and shift, which is we've done ourselves many times. But it's then you start looking at, okay, how do we improve? What do we need to start doing to start leveraging more cloud capabilities so that we can start using more of the platform? Because rather than doing it ourselves, whether that's service discovery, networking, storage, and various other things. And then also other things become more important as well, like cost. If you're using a cloud service, for example, a managed cloud service, AKS, GKE, EKS, then suddenly cost becomes a lot more important as well. So maybe you want to be, reducing those costs and using more cloud-friendly technologies, and the things you're doing maybe more cloud-friendly languages as well. So I think it's just a constant journey, but maybe we're looking at it slightly. We're starting to look at the priorities slightly differently, which is quite interesting.
It's also interesting, just another point of that topic is, so this is just one example service, but it's an interesting one to think about. There's something from Google called Google Cloud Run. And Google Cloud Run is available in two forms. One form just runs inside your Kubernetes cluster. And one form is, true serverless. You don't manage any infrastructure, but it looks the same. And the really interesting thing about Kubernetes, like long-term, it might even disappear completely, but it looks like it's there. Like everything looks like it's Kubernetes. So if you're using Cloud Run today, there's a version of Cloud Run where there isn't even any Kubernetes there, but it looks like it. So for me, the big thing about Kubernetes is it's a way of working with APIs in a consistent way. Whether or not there's a Kubernetes cluster, whatever runs in or out of your Kubernetes cluster, it doesn't matter. There's ways of using secrets, that the secrets are not in your cluster. They may appear sometimes when you need them in your cluster, but they're managed outside. I think one of the lessons of using the cloud well is use as many native cloud resources as you can, for storage, for databases, for single sign-on, for IAM, for almost anything in software. The tendency is to actually move it out of Kubernetes, but that doesn't mean Kubernetes is not totally awesome. It's a way of doing everything, but all the cloud resources almost look like they were a fundamental part of Kubernetes at the same time. So it's a very interesting, it's an awesome time to be a developer, quite frankly. Another thing that's really interesting, by the way, is let's just talk about the service mesh space for a second, because that's really interesting because there's lots of different options right now, right? Linkerd and Istio are the two big ones, but there's a bunch of other things out there that do different parts of the puzzle in different ways. The interesting thing is you could pick one of them. Let's say you go with Istio today. You could pick Istio, and then if at any point in time you bang your head on something in Istio and you think, oh, I really wish there was something else that did this one little thing I need, you could look at, say, Linkerd, and maybe Linkerd does the thing that you need that's slightly different from Istio. You could switch from one to the other really quite easily. So a lot of the IT landscape for a while has been bets, like I'm betting on Java, or I'm betting on Windows, or some random big bets. Now, once you're in this cloud Kubernetes world, we can all just opt in or out of different bits of technology when our use case suits it. For example, Cloud Run, I could run Cloud Run in my cluster or out my cluster, or I could go to Lambda, or I could go to Azure Functions. Now we're in this really interesting world where there's very little in the way of lock-in, and it's very easy to switch between these different technologies, and they all look and feel very similar. They're all API backplanes and control points and whatnot. They all work kind of the same from a developer's perspective. So it's a very, very interesting time that we can pick and choose all the little bits of technology we need to go forward. The challenge with all this, though, is what do you pick? And this is the big problem, I think. If you're coming to Kubernetes for the first time ever, it's like, so look at CNCF landscape. There's 5,000 things. Pick 10, and off you go. And you're like, which 10? I know the challenge. What we've tried to address with Jenkins X and whatnot is how can we give people a clue at where to start? Because the world is awesome, but it takes a long time to find, like, how do I build a container? What do I use for security? How do I manage secrets? Which container registry should I use? Which cloud should I use? How should I package my workload? How should I do secure containers and version things? And there's a lot of decisions to be made. And I think that's the biggest problem right now, is making a million decisions so you can get.
Yeah.
And continuous as well, though, because it's always evolving. Like, it's a constant moving target, isn't it? Because as soon as you wrap your head around one thing, there's another new thing that kind of pops up, which you then have to start learning as well. And you don't know. You need to. Do you just go and prioritize having? Spend. You might have spoken to your boss and say, look, I need 2 weeks to figure this thing out, and you solve that. And then at the end of the 2 weeks, somebody will ping you a link to say, oh, look, there's this new open source thing out which does a similar kind of thing, and it's awesome. And you go, do you go back to your boss and ask for another 2 weeks, or do you kind of plow on forward? It's really, really hard to either consume all the information, but also understand at what point it's ready to kind of take a punt on something, or to invest your time and without and then start relying on those projects as well.
I think one good bit of advice, by the way, from our journey. So we've been on a journey for 4 years or so of just gradually trying to make CI/CD usable, or as usable as we can, right? And it's on the cloud, because we spent a lot of time trying to figure out how to get Vault to work in. And now here's Vault as a service, and you're like, oh, that's so much easier to use. So I think using
James is coming in and out.
Oh, okay.
What was the big bit of advice there?
Get better internet. That's the advice. No, but it is, to me, I see it as a huge problem right now, is that I believe that we are now in a phase that everybody agrees Kubernetes is a thing. We're going to use Kubernetes. Kind of like, there is not much doubt about that. But then I think that most of the people are confused. Okay, so, and what's on top of Kubernetes? How do I build container images? Docker, and then I do, no, that's horrible. Kind of like, and then somebody else comes with something else. No, that's also bad for. So we're really missing as industry, I believe. Or at least Kubernetes community, we're missing some sort of sane standards. So you don't have to build images like that, but this is what we believe that by default should be there. And the same thing with service mesh. It takes like 1 year just to pick a service mesh after you understand halfway through how it works, right? And it's a real problem, I believe, because we cannot expect we are spending most of our time with Kubernetes, but most people are not that lucky to say, okay, I'm going to spend 7 hours a day picking service mesh.
And it's how they relate as well, because I guess in that landscape you both mentioned, lots of awesome projects, but how do they work together to solve a problem that we need to provide a solution? One of the things we've been looking at around with the CDF, the Continuous Delivery Foundation, is looking at, rather than just open source projects that get put out there, but how can we work together to provide better solutions and help you guide people in more of this, I guess it's an opinionated way, but more just looking at how we solve problems rather than together, rather than just putting everything out there for people just to try and wrap their heads on and try and glue together themselves. And it's not going to happen overnight. And I think it's more and more people to try and get involved in trying to work out what the problems we need to solve together, and then come together and providing these better solutions that people can actually reuse and contribute as well. It's not just contributing from an open source coding point of view, but contributing how we work together and provide those solutions.
Even imagine you work at a large company and your company's chosen, we're just going to use Amazon for everything. So everything's Amazon, and you go, oh, okay, that must make things easy then. Imagine you want to run a container. So you could use EC2 and you could spin up some VMs and you could run Docker in there. You could use kubeadm and you could boot up Kubernetes yourself on EC2. You could use EKS, you could use ECS, you could use Fargate, you could use Beanstalk. And so what's going to happen at almost every large company, everybody uses every possible way you could do anything, because that's just how the world is. Everyone's going to try everything in every company, and every company is going to have a million different ways of doing everything. And then over time, we're going to have to try and figure out, well, who's running a container here? I have no idea. And I think that's a very big problem for our industry, of how to even understand what we're even doing. Because these cloud services are really, I mean, they're awesome, but they're also, there's so many of them. I mean, you know, Amazon has what, 5,000 individual services?
It's madness.
It's madness. I mean, even just understanding the console is madness, quite frankly, but understanding what a company as a whole are doing with one cloud provider. And then imagine there's, you know, 3 cloud providers at least, and lots of other associated cloud services out there. I think there's a very huge problem, I think, for businesses to comprehend what's going on and deal with all of this. Even if there was an amazing open source project that tries to help with these kind of problems in CI/CD, I think there's only so much an open source amazing project could do, right? There's big challenges for us to address.
So now that you mentioned the amazing open source project, what does it do? Which one is it? We don't know. I don't know. Which one are you talking about? I don't know.
I'll give you a clue. So we've been working for a couple of years on something called Jenkins X, which we've been trying to focus just on a very small piece of the puzzle of how can we just do CI and CD, which doesn't sound that big a deal when you say it like that. Oh, it's just CI and CD. But it turns out to even this apparently simple, small problem is really quite challenging. You know, what container registries do you work with? How do you make the images? How do you store Helm charts? Which version of Helm do you use? How do you deal with Helm? How do you deal with a thing called GitOps and managing immutable artifacts across environments? How do you do promotions? How do you do preview environments so you can preview changes before you merge a pull request and so forth? So we've been really trying to focus on, firstly, what are the best of breed tools that can help in the CI/CD space? So ideas like GitOps, tools like Helm, tools like, well, obviously Kubernetes, container images, what's the best of breed container registries you can use with those container images? How do you use secrets well? What tools out there to use secrets? All the cloud vendors have a secret manager of sorts, plus there's this thing called Vault, and going through the whole range of technologies. There's lots of technologies that just build container images. There's things like Canico and Scaffold. There's cloud services like Cloud Build and various other things. And so really we've been trying to just glue together the best of breed tools to help developers become productive in CI and CD without them having to sit there for 3 years and glue together by hand with bits of string all of these different tools. It's surprisingly challenging to do a really good job of helping everyone move forwards easily, because we keep finding all of these challenges of, you know, how do we make it super easy to install with certificates and TLS and cert and DNS. The whole idea of helping people do CI/CD turns out to be really quite a challenge. We thought we'd be done by the end of last year, but no, it seems to just grow and grow and grow in scope and need. But it's fun. If nothing else, it's fun, and we learned a lot, and we're enjoying it. I think you wrote a book on it, didn't you, Victor? Which is really awesome.
Oh, yes. Yes, I did. Yes, I did. and I hate every minute after making that decision, because I spend more time rewriting the book after you guys than doing anything else. Just when I finish a chapter, you come up and tell me, no, not anymore. No.
It's
No,
actually an
sorry about
interesting thing. It's actually an interesting thing, though, isn't it? I mean, even just that point there, it's this whole idea of continuous improvement, trying to constantly looking at how we can do things better, and not doing large chunks of work, because bigger chunks of work can bring bigger risk of change. But how do we? Because we use Jenkins X to build and release Jenkins X, so we have a lot of releases a day. But how do you consume that? I mean, Victor, you were saying about rewriting chapters or improving these chapters, because constantly there's a lot of contributions from OSS, and CloudBees actually have a number of engineers that are constantly adding and improving Jenkins X. But how do you consume all of this as well? So it's another way. It's a good side effect, I guess, from continuous delivery, having these smaller changes, more rapid changes. But then how do you consume this as well in a consistent way? And it's one of the other challenges I think we've really learned from Jenkins X, and we haven't solved it yet, but we're focused around that. How can we make it so it's easier for people to consume these changes as well? Because they can have to have that problem themselves. As the State of DevOps reports and accelerators telling us, we want to have more higher reduced change failure rate, but also mean time to recovery, but also lead time to change. So we want to be, having a smaller time it takes for come up with an idea, to have that actually rolled out. But then how do we, but that's all very good. We can throw a lot of changes, but how do we also consume that and make sure that we're set up and ready to be able to handle this volume? So we need to invest in better automation around monitoring and alerting, and the feedback loops need to be right the way circled back to the developers, so they can learn how things are operating and how things are working well, those changes are affecting as well. So it's interesting that the scale of all these changes, it really does, it's just so broad, as you were saying, James, which then opens up automation.
And I think it's worse than that, because not only is the landscape changing all the time, we're improving all of the different ways of doing everything at the technology level. At the same time, everyone now wants to do Canary and progressive delivery. Everybody wants to do A/B testing. Everybody now wants to do testing in production. Everyone wants amazing observability, so that if anything weird happens in production, you get fast feedback and you can iterate. So it's not just everyone wants to do CI and CD. Everyone wants to adopt, chaos engineering and various other kind of pieces. So we're all trying to do lots and lots of things differently, which is great because we're continuously improving. But now almost everybody needs to really get their heads around what canarying are, what feature flags are, what all of the guidelines in the Accelerate book and chunk-based development and those kind of things, and understanding using feature flags so you can do incremental development on the master branch while moving features forward, and then use A/B testing across your feature flags, and then progressive delivery. It's a challenge, really. It's a huge challenge for us all.
But I think that relates back to what you were saying before. When you were making an analogy of, okay, now in a company, developers are going to try all the permutations of building container images or whatever was the example, and we end up with 5,000 different ways to do stuff, which I believe is great because that's innovation. We are really trying what works better. But on the other hand, we cannot continue doing that because that means that we are not really doing any real work. So it's very hard for me to find that balance between, okay, so yes, let's experiment and let's find 5,000 ways to build images, but on the other hand, let's do some work as well. If you go to one extreme or the other, either you end up being a equivalent of mainframe type of developer, this worked 30 years ago, so I'm productive in it. Or you end up in a huge mess of not doing anything, unless you find that some sort of a balance. You cannot be here or there. It's in Kubernetes world, I don't know how to find that balance, because literally as soon as I discover something, somebody tells me, no, that's old news. No. You're a week too late. You jumped on the train week too late.
And I think another... Also, well, I was just going to say, another part of that as well is, as engineers, software engineers, like James was saying, it's a hugely exciting time. I mean, it's an amazing time to be a software engineer and working around containers, Kubernetes. It's major. So one of the other interesting things, as you said there, Victor, you could have the most amazing integrated, latest technology, latest service mesh, however, best Kubernetes solution based on Kubernetes, but you might have, your business, you may not have added any value to your business because you've been focusing on developing how to pull everything together. And from a software engineer, keeping your skill levels up so that you have the knowledge of what all these new service meshes are, and you have that experience. So it's interesting because you then also, it's quite easy, I think, for software engineers to kind of play with the latest thing, but then almost not, start forgetting about the business value as well that you need to be bringing in for your company, which is often another, trying to keep software developers focused on delivering value for the company is also, I think, another challenge as well, which is aside from all the latest technology.
I was just going to echo what you just said, James. I was going to use, like Adrian Cockcroft has often said, you've got to avoid undifferentiated heavy lifting. And I think one of the challenges with Kubernetes is it's so easy to do everything by hand. And we've done this ourselves over the years. We started by saying, I know, let's install and manage our own Nexus to manage artifacts. And then we've had to back up the disk, and we've had to figure out how do we auto scale it. And then we've had to do all of this kind of stuff. And then suddenly it's like, well, why don't we just use the container registry in the cloud provider, because then they manage it. And so there's a whole lot of stuff that happens in the cloud where you can build your own custom solutions, but then you're basically doing undifferentiated heavy lifting. And so for me, part of the using the cloud well is if ever you can outsource something to your cloud provider so you don't have to manage it anymore, just do it, because it saves you time and effort. And the downside of these 5,000 different options is 4,800 of them are DIY solutions that you then have to manage for the rest of your life. If you can outsource that to the cloud provider, whether it's a cloud provider's disk storage, blob storage, container registry, secret management, whatever the hell it is, the more you can delegate to the cloud provider, the less work you have to do, and you can focus back on your day job. The more you do DIY service meshes and DIY container registries and DIY everything. Now, I know this is an interesting thing that we've often talked about, Victor, is the nice thing about Kubernetes is everything could be container agnostic and cloud agnostic and provider agnostic. But the more you go agnostic, the less you're using the cloud well. So if you want to stay agnostic all the time, it means you're basically doing lots of differentiated heavy lifting that's undifferentiated, but you're differentiating to make it cloud agnostic. The more you delegate to the cloud provider, the less work you have because the cloud provider is managing everything. Like, no one should be installing and managing Kubernetes themselves on a cloud provider. That's what cloud providers do. But the same applies to storage, secrets, security, networking, databases, machine learning. Almost everything in software now, you should be delegating to your cloud provider, really.
But that's why kind of what I would really like to see is, I know that there are efforts in that direction, but I would really like to see Kube API truly extending beyond scheduler. Kind of you're meshing services. Now, my problem with using, I don't know, AWS services because I'm in a way locked in. But if I could create S3 buckets with Kube API, which I cannot right now without some hacks, kind of that would be awesome. If we could, I mean, basically, what I want to say is tell Kubernetes, look, I need a service to have cheap storage. I mean, I'm simplifying it now. And then don't give me that S3 thingy or whatever it's called in Google, kind of like, I should not care about that.
Things are moving in that direction. We don't quite have the definitive canonical Kubernetes CRD that deals with all of those things, but there's a Google solution that I've totally forgotten the name of right now, that everything's a CRD. Can you remember it, James? The Google one?
I'm trying to remember it. No, because it looks really great.
It looks really great. And there's an Amazon one as well that basically define custom resources in Kubernetes for everything, all of the main, the buckets and storage and IAM roles and all that kind of stuff. So there's an Amazon version, there's a Google version, I think there's an Azure version. There's also the Kubernetes cluster API, which is slightly different. That's about how do you use custom resources to define clusters. And then you have implementations for Pivotal and all these different providers. We are moving to this world where everything looks like a CRD, and the differences between a bucket on Google versus Azure versus Amazon is just a little few annotations on the CRD somewhere. So I agree. We are moving in that way, in that approach. We're not quite there yet, but it does look like the planets are kind of aligning, and we're all heading to this future where there's just a bunch of canonical APIs for making everything, and we're not so deeply coupled to, say, Google or Amazon or Azure. I remember like when people were having OpenStack debates and people were saying, should we reverse engineer the Amazon API in OpenStack so we have like a plan B? The nice thing about this adoption of Kubernetes APIs is you could have an on-premise version of something that looks like S3 that uses Minio or whatever and uses custom resources to make it. So there are ways of doing it, but I can't help think really we should almost imagine everything's the cloud now, really. As you could probably say there's only like 6 clouds that are worth thinking about anymore. You know, at the big 3 cloud vendors, Alibaba, IBM, and VMware is probably most of the clouds. Oh, DigitalOcean. Maybe there's 10.
DigitalOcean.
DigitalOcean. Sorry, I missed those off. Okay, maybe 7 or 8. I don't know, something like that. But increasingly, I think they're all going to merge conceptually in terms of API. You know, that they're all doing different on-premise, hybrid, public cloud offerings in different ways, so that you can have an on-premise couple. So I think we're slowly moving to this world where we could almost treat all of these different clouds as similar. There was always going to be differences, but we can kind of, from a developer's perspective, we can treat them similar. Like as a developer, ingresses look about the same. You know, Istio looks the same, whichever cluster you're on. Most things look about the same. There are some specific differences in things like IAM roles and things like workload identity versus the Amazon version and the Google version and stuff. There's some differences, but most of those, from as a developer level, they're fairly consistent. It would be nice to have a higher level abstraction that just hides all this stuff from developers, because developers shouldn't have to worry about this low level detail, but we get it there. We get it.
So I think that we need to start closing, which is very unfortunate. We should. I was about to say something and then I cannot. Anyway. So
you can't not say it.
You didn't want to create more work for me, is what you're saying.
Exactly. That's the thing. Yeah. So we need to do this again. Continue.
It was fun.
I don't know. Darin is the closing man.
Oh, I am?
Yeah.
Okay. Well, I'll close it. James, thanks for hanging out. We're really live, so it's like...
Thanks for having us.
It's been a pleasure.
And hopefully for everybody that's listening right now, and I'm going to go ahead and sort of remove the Jameses from the screens. Here we go. So Victor, it's me and you up on screen.
Yeah, it's you and me.
All right. But now I'm going to boot you out. Okay, that was a little too rude. You can wave now. Okay, here we go. All right. Thanks for watching. If you're listening to this on the podcast, if you're watching the replay, please go ahead on YouTube, go ahead and subscribe, ring the bell so you can do that. If you're listening via podcast and you haven't subscribed yet to the podcast, please go ahead and do that. This will probably be up for people actually watching live, be on the podcast probably within some time this week as a bonus episode. And that's pretty much it. So thanks for hanging out with us today. Everybody have a great day, and we will talk with you later.